All right. So, good morning, everyone. Okay. All right. So, good morning, everyone, and I'm Mr. Muriuki. I have met most of you in previous lessons, and today we want to look at chemistry and specifically a topic by the name of energy changes in chemical and physical processes. So, as you can see from the heading, this topic is going to deal with energy changes that occur when we have a chemical or a physical process. And I know that up to this point, you people have come across so many chemical processes and so many physical processes. An example of a chemical process or a chemical reaction is a reaction between an acid and a base. So if I was to react an acid like HCl plus a base like this one to form a salt plus water, this is a chemical process. Now, I know that because you have done so many of these things up to this point, you must have realized that if you hold a beaker in which you have an acid and then add a base there, your hand feels warmer, meaning that some heat is being generated and then that heat is released to the environment. The environment is the beaker where the reaction is taking place. It's your hand, it's the surrounding air, etc. And that is why your hand feels warmer. And in fact, if you placed a thermometer inside a beaker in which a reaction like this one is taking place, there would be a change in temperature. You either see the thermometer recording an increase or a decrease. That is an energy change. It's a change in energy, meaning that as this chemical reaction or process takes place, some energy is either released to the environment or absorbed from the environment, leading to a change in the amount of energy that was in the reagents or the products formed. So that is a chemical process. A physical process is a process like melting, like evaporation, like sublimation, like deposition. Those are physical processes. And when such a process takes place, heat energy may be absorbed from the environment or it may be released to the environment. Now, energy changes leads to two types of reactions. A reaction that we call exothermic reaction, and endothermic. Reaction. An exothermic reaction is a reaction in which energy or heat is released to the environment, while an endothermic reaction is a reaction in which heat is absorbed from the environment. When heat is released to the environment, that is endothermic reaction, the environment feels warmer. This is what I'm talking about. You have a beaker here, and you have HCl, then you add NaOH. The amount of energy in this mixture here was X joules. The amount of energy was X joules. But as the reaction takes place, the heat races from X to X plus 40 joules. This means that some heat has been absorbed from the environment. That is an endothermic reaction. For an exothermic reaction, it would be X minus 40 joules. In an exothermic reaction, the products formed will be at a lower energy because heat energy has been released to the environment. In an endothermic reaction, the products will be at a higher energy because heat energy, or rather energy, has been absorbed from the environment. Now, students get confused around these concepts. They mix energy, also referred to as enthalpy in this topic, although there are quite some differences, but for the purposes of this lesson and this topic, we are going to use the two terms interchangeably. So, students get confused. An exothermic reaction is a reaction in which energy is given to the environment, when energy is released to the environment is receiving energy, and therefore the environment will feel or will be at a higher energy. So if these were the reagents, HCl and NOH, and the temperature was, say, 24 degrees Celsius, if this reaction is exothermic, at the end of the environment, the temperature will have increased so that it will be probably something like 30 degrees Celsius. So this is the temperature of the environment. The environment is the beaker, it is the water, it is the air around, it is the hand with which you're holding the beaker, etc. So the environment has received some energy, and therefore the temperature will increase. In this topic, when a reaction is exothermic, we denote that using a positive sign, not a negative sign, and when a reaction is endothermic, we denote that using a positive sign. Let me clarify this. We have HCl reacting with sodium hydroxide to give you sodium chloride plus what is that now? Plus water. This is a chemical equation. If I introduced the energy change when this reaction takes place, then what I would be writing would be something that we call a thermochemical equation. Thermochemical. A thermochemical equation is an equation that shows the reaction taking place, and then alongside that we have the energy change. We have the energy change here. Energy change, I said that we can also denote energy using the, or we can call it enthalpy. Enthalpy. And the symbol for enthalpy is capital H, like that. We are all familiar with the term change in, and in science, change in is denoted using delta. This one, delta. So enthalpy is the heat content of something. For example, HCl resting in a beaker. The heat content is, say, like 40 joules. That is the enthalpy of this one. The heat content of sodium hydroxide resting in a beaker, that is the heat content, enthalpy H. So when we have a reaction taking place, the heat content, the enthalpy changes, and we're going to call that delta H. So delta H refers to enthalpy change. And I'm saying, if I was to write an equation like this one, and then alongside I write delta H is equal to negative 423 kilojoules, then what I would have here is a thermal chemical equation, an equation that shows the chemical changes taking place. Of course, if it's a physical process, then it will of course be showing the physical process or the physical changes. So an equation showing the changes, and then alongside we have the enthalpy change, is known as a thermochemical equation. And I was saying that for an exothermic reaction, the enthalpy change is negative, meaning that heat is lost from the reagents to the environment. Now, if at all the heat content here was, say, like 1243 kilojoules, it means that the products here will be at a lower energy, 800 and something, so that the change is 423. So 1243 minus 8, whatever it is, that figure, the difference, so that the change is this one. That is an exothermic reaction. The products are at a lower enthalpy, a lower energy than the reagents. For an endothermic reaction, for example, if you were to dissolve something like ammonium nitrate, for an endothermic reaction, the enthalpy change here is positive, indicating that the products are at a lower energy, rather a higher energy than the reagents. the reagents absorb heat from the environment, so that the new energy here from 1243 we have 1634 or a higher figure. So the enthalpy change for an endothermic reaction will be positive. So it's very easy to confuse these two terms and whether it's negative or positive, but it's also very easy to remember them. Just remember, exothermic heat is lost. So if these were the products that are reacting, if this is my product, for an exothermic reaction, heat is lost. So that is minus. Whatever the value was, minus that one. For an endothermic reaction, if these were the products reacting, then heat is gained or energy is absorbed from the environment, and therefore that is a positive change. So that is it regarding enthalpy change. And as you can see, you're going to denote enthalpy, or rather to, in equations, you can show enthalpy change by writing the enthalpy change here alongside the equation in what we are calling a thermochemical equation. Now, I want to introduce another concept. I don't know whether there's a question. We okay? All right. I want to introduce another concept, and that concept is energy level diagram. An energy level diagram is a graphical representation of what happens to the energy or the enthalpy of products and reactants within the course of a reaction. This is what I'm saying. Consider this graph showing the energy or enthalpy on this side, and this is going to be in kilojoules, and then this is reaction progress. Reaction progress or path. It could be in minutes or in seconds, depending on the how fast the reaction is. Now I want us to use the same reaction that I was using, sodium hydroxide reacting with HCl. Now the energy content or the enthalpy of the reagents initially, we're going to place it here, just a figure I'm picking, and we have HCl reacting with sodium hydroxide. Now this reaction here is exothermic, so that implies that the product will be at a lower energy. Heat energy, rather energy actually, will be lost to the atmosphere or to the environment, meaning that the product will be at a lower energy. So the product will be somewhere here, and that is right there. So this difference here, that difference there, is the energy change, that drop, and it shows that heat energy was lost. Let's just call it energy, was lost from the products, rather from the reagents, so that the product at a lower energy. So this one here can be demonstrated or can be indicated as delta H is equal to negative, I think I used 423 kilojoules. So that one will be indicated there, right there. That the energy change can be shown here. So this is what we call an energy level diagram, a graph showing what is changing, rather how energy is changing from the product to the reagents. As you can see, for an exothermic reaction, the products are at a lower energy. Heat is lost, and the value here is negative, so delta H is negative. For an endothermic reaction, on the other hand, the product will be at a higher energy, as compared to the reagent. So we could have A reacting with B to form C and D, and delta H here is positive something. So, this is enthalpy on this side, and this is reaction part on this side. So, an energy level diagram tells you, was heat absorbed from the environment or was heat lost to the environment? So, when the reaction is endothermic, the movement, or rather the enthalpy, the enthalpy change will show us an upward movement. But if the reaction is exothermic, then the movement will be downwards, meaning a negative change, and on this side a positive change. And that is what you call an energy level diagram. I don't know whether my students are following. Any question on that side?
It's no question, but Mesa Wakehu is saying great job. Nakuona content in a flow.
Mesa looks like she was one of my college mates in Maseno University, I think.
Yeah,
she could be the one. Yeah. All right. So let's move on to something else.
I
don't know whether I'm live on Facebook or in the group. It's okay.
So, I have to finish this one.